Hi all. This recording is about for loops, the basics of for loops and how we use for loops in solving or writing the logic where we have repetition. So let's begin with the for loops. The basic idea or the basic syntax or the basic premise for loop is that let's say let's say I have to accept five numbers from the user. Let them be of float data type. So I'm accepting five different values from a user and I'm computing their average. So here is where I'm accepting the five values for the variables A to E. And then here I'm computing the average and displaying the average. So now in case of five variables, it's manageable. I can do it. But what if the number of variables are more? Meaning that if I have to do something like accept like, for instance, say 5,000 rather than five. So I cannot keep on, you know, create variables for each of the 5,000 numbers the user is going to input, but rather we want to come up with, a simplistic way where we can accept user input for n number of times. The n can be 5, 10, 100, or 1,000, and then simply, compute the average of it and return back to the user. That's where loops come into picture, and we'll see how we can solve these problems with for loops especially. And also, another motivation to learn for loops is that let's say I have this block of code where I wrote like seven or eight cout statements, and I'm simply doing is I'm displaying the values 2 to 16, all even numbers between 2 and 16. And the way I'm doing it is I ended up writing multiple cout statements. But if we see, most of this part of code is repetitive except for the values 2, 4, 6, 8, and so on. So wherever there is a repeated value or repeated task, we can use loops, and we can use for loops as well, and see how it works or how we can reduce the code repetition and try to reduce the number of lines of code. And to begin with, a for loop has three important parts, which are uh, initial statement, loop condition, and an update statement. So if I were to write a for loop, I'll start with the keyword for, and I'll give both opening and closing parenthesis. And we have something called as initial statement. And then we have loop condition. And then we have something like update statement. And anything that we write within opening and closing braces, that's what we call a for loop body. So this is where we have the initial statement separated by a semicolon. We'll have a loop condition separated by another semicolon. We'll have an update statement. As soon as we have all the three, initial, loop condition, and update statements, then we will open a brace. We'll write whatever the content that needs to go inside the for loop. We call this as for loop body. And then we'll end the for loop using another like a closing brace. So this is a general syntax of a for loop. And let's see how the syntax is, or how we write code using this syntax. So let's say I have a particular code snippet where I'm starting from values 1. So my bad. Okay, it doesn't work sometimes. So let's say I'm writing a code snippet in this manner for int I equal to 0. So this is what the initial statement is. We will typically initialize a variable in the initial statement. In this case, I'm initializing a variable called I, and I'm initializing it with a value of 0. And the I here is what we call as an identifier in general. And like how we have seen naming rules for variables, like they have to start with an underscore or an alphabet followed by numeric characters and so on. In the same manner, all the rules that apply for naming a variable The same rules apply for an identifier as well. So as long as it's a valid identifier in C++, we are good to use any identifier. It's not necessarily that we have to use the identifier I. And the task of this program is to print numbers from 1 to 10. So I'm starting it at 1. That's my initial statement. Now, as soon as I declare or write this statement, or as soon as a computer runs this statement, what it does is it creates the variable I inside the memory and gives it a value of 1. So this is the snapshot inside the computer's memory. Now, we have a loop condition. The loop condition is I less than or equal to 10. So this is where a for loop begins. It starts with initializing a variable. And as soon as we initialize a variable, computer will create that variable inside memory and it populates it. In this case, I'm creating this variable as 1. I'm starting at 1 and I'm going all the way till 10. This is loop condition. So loop condition is something that will be evaluated to either true or false. In this case, the value of I inside memory is 1. So 1 is less than or equal to 10, which is evaluated to true. So loop condition can either evaluate to true or false. So it's something like true or false outcome. So if it's true, that means the computer will execute what's inside a for loop. And what's inside a for loop is nothing but whatever the lines of code that we write between the opening and closing braces. And this is what we call as the body of a for loop. So once, if this condition is met or if this condition is evaluated to true, then the computer will execute whatever that's inside the for loop. Now, inside the for loop, all I'm doing is that I'm simply printing the value of I and I'm ending the line so that the console moves into second line. Now, this is the state of memory. The value of I is 1 and I'm outputting 1 to the screen for the user. Up next, the third part of the for loop or third component of a for loop, which is nothing but an update statement. In the update statement, I'm updating the value of I, or I'm adding the value of 1, or I'm adding, or I'm incrementing the value of I by 1. That means whatever the value of I is there inside memory, I'm adding 1 to it. Now the value of I inside memory is going to be 2. So this is what we mean by an update statement or an increment statement in this case. So I have a C out, printing the value of I, and I'm simply going to a new line. So this is my simplistic for loop. So we start at initialization. We check the condition. If the condition is true, the compiler or the computer will print the value of I. Once it prints the value of I, it goes and updates the value of I. So this is what happens when the update statement is executed. The value of I inside the memory is incremented by 1. Now, again, we start at loop condition. This time we won't go back to the initial statement. Initial statement inside a for loop will only be executed once. So now, once the update statement has been executed, it goes for the loop condition. Now for the loop condition, the current value of I inside the memory is 2. 2 is less than or equal to 10. That means this is again evaluated to true. That means the computer will execute what's inside a for loop body. So now the value of I inside memory is 2. And whenever we are trying to print it, the value is going to be 2 on the screen. Now again, the computer will execute the update statement. By update statement, we are incrementing the value of I by 1. Whenever we are incrementing the value of I by 1, the same will reflect inside the memory. So 2 plus 1 is now 3. And as soon as that, again, the computer will execute the loop condition. The current value of I inside memory is 3. 3 less than or equal to 10, which is true. The computer will go inside the for loop body and it will print the value of I. So now, as of now, we have executed the loop 3 times and we can see the output 1, 2, and 3. In this manner, the computer will loop between update statement or check the loop condition, whether the loop condition is evaluated to true or false. If it is true, then go inside the for loop body, whatever that the content is there inside the for loop body, execute it. And right after that, execute the update statement. So whatever the update statement, it can be either an increment or decrement. And in the example that we have just seen, we're doing an increment. So run the increment statement and again started checking the condition. execute the contents of the for loop body if the condition is true, and then execute the update statement. So in this manner, a for loop will repeat, or in this manner, how a for loop is executed. And now the question is, until when does this repetition continue, or to what extent does this repetition continue? So this repetition continues until the for loop condition is evaluated to true. So now let's say after some iterations, the value of I in memory is 11. So now when the computer checks for the loop condition, when the I value is 11, 11 is less than or equal to 10, which is evaluated to false. So once this is evaluated to false, the computer will come out of the for loop. It will not go inside the for loop body, but rather it comes out of the for loop and executes whatever statements are there after the for loop. So let's say if I have a print statement after the for loop, then after cross-checking the condition, 11 is less than or equal to 10, since it's false, the computer went ahead and executed a print statement saying displayed 10 numbers. So that's how a for loop works. And overall, this repetition, every time checking the for loop condition, running whatever the code that's inside a for loop body, and then updating, this entire thing is what we call as a repetition, or we also call it as an iteration. So iteration is nothing but how many times, or each time, checking the condition, executing the for loop body, and then updating the for loop variable. This entire process is what we call as an iteration. And in this case, I'm iterating, or I'm iteratively printing values from 1 to 10 using a for loop. And eventually, when the I value is 11, by now we have displayed values starting from 1 to 10 to the user on the screen. And once the I value reaches 1, thanks to the update statement, once it reaches 11, then 11 less than or equal to 10 will be evaluated to false, and hence we will not go inside a for loop, but rather exit the for loop and start running whatever that's there after the for loop. So this is how a typical for loop is executed. And now there are certain essentials of a for loop. It is essential that we don't want to repeat a for loop for infinite number of times, and also we do not want to write a for loop that never gets executed. So it's like a fine balance. I don't want a for loop that will be never executing, or I don't want a for loop that executes infinite number of times. So as a programmer, whenever I'm writing logic for loop, it is essential that I have to ask certain questions and answer them, so that my for loop is executed, but not executed infinite number of times. So let's take the same example, printing the values from 1 to 10. So the questions that I'm going to ask are, what is the variable that controls the execution of the for loop? So on the left hand side, we have a for loop. And now in this for loop, which variable is controlling how many times the for loop is executing? So the answer for this would be the variable I. So the entire for loop execution is based on this variable I. What is the starting value of I? What condition am I checking? Whether this condition is true or false. And how am I updating the I value? So these are the questions that we need to ask. So now we know which variable is controlling this for loop. The variable that's controlling this for loop is variable I. And now what is the initial value of this variable I? The initial value for this variable I is 1. So we are starting at 1. And till when am I running this loop? I'm running this loop until this condition I less than or equal to 10 is false. Once it is false, I no longer run what's inside a for loop body. Until this condition is evaluating to true, then I'll run whatever the code that's inside the for loop body. So this condition statement, when the value of I is 11 or greater than 11, this condition is going to be false, and that's when I'm going to stop. So I'm going to start at 1, and I'm going to stop when I is 11. And am I doing something so that I reaches from 1 to 11? Yes, I'm updating I, I'm incrementing I by 1, so that I'm taking steps from 1 to 11. So this is where we are starting. We are starting I at 1. And whenever we want to stop, or whenever the for loop stops, the I value will be 11. So what am I doing so that my code execution starts at 1 and stops at 11. To do this, I'm writing an update statement. So these are the questions. Where am I starting? Starting at 1. When will I stop? I'll stop when the I value is 11. So now what am I doing so that I start at 1 and I eventually reach the stopping condition? To reach to the stopping condition, I'm incrementing I by 1. So thus, by answering these sort of questions, I can come up with a for loop that never gets stuck in an infinite loop, and I can come up with a for loop that executes as well. So another code snippet. It's not always necessary that we have to write a for loop with positive integers. I can write a for loop with negative integers as well. So now let's see. I'm starting at I is -1. So the first question is, which variable is controlling this for loop? The variable that's controlling this for loop is going to be variable I. And where am I starting it? I'm starting with a value of -1. And when will I stop? The for loop will stop executing if the value of I is greater than or equal to, if the value of I is greater than -11 or equal to -11. So whenever it is -11 or, whenever it is -11 or less than that, the for loop execution will come to halt. So that's when we are going to stop. So this is where we are starting and this is where we are going to stop. And what am I doing so that the value of I becomes -11 and eventually the for loop execution stops? I'm writing a decrement statement inside the update part. So thus, I'm taking steps so that I'm starting at -1. I'm eventually reaching -11 so that the for loop execution stops at a particular time. And to do this, -1 to -11, I'm decrementing I value by 1. So thus, by answering these series of questions, I can write better for loops which never get stuck in infinite loops. Up next, I have a for loop to sum up all the even numbers between 0 to 100. So again, it's not necessary that I have to always consider the variable I. In this case, the variable j is going to control my for loop. I'm starting at 0 and for loop execution halts or stops when the value of j is 101. So I'm starting at 0 and I'm incrementing j by, steps of 2. So start at 0, stop it when j is 101. And what am I doing, or am I updating j? I'm updating j, and this time I'm updating it by 2. So again, the same scenario, j start at 0 and go all the way till j is 101 or, greater than 100, I can say. So when j is greater than 100, we'll stop. And am I modifying j so that j becomes greater than 100? Yes, I'm modifying. And how am I modifying? I'm adding 2 to j after every iteration. So that's how I'm ensuring that my for loop executes, but does not execute infinite number of times, and it comes to a halt at a particular point of time. And lastly, is it always that I have to use an increment operator? It's not necessary. Now, in this case, I'm starting at 99 and I'm going all the way till 0. And if j value is negative, like -1, -2, then the stopping condition will be met. And in order to ensure that I go from positive value to negative value, I'm decrementing the value of j by 2. So thus, start somewhere, stop somewhere, or ensure that you stop somewhere. And what are you doing, or how are you ensuring that your for loop will stop? So all these three synchronously will ensure that we are writing good for loops and for loops that never get stuck in an infinite condition or infinite state. And sometimes I can write a for loop so that I even inside my for loop body, I can update the value of I. For instance, consider here, the value of I is 0 at the beginning, and the for loop execution will stop when the value of I is 11 or greater than, say, 10. Now, how am I updating I? I'm updating I inside the for loop body. So when I start, the I value is going to be 0, 0 less than or equal to 10, true. Print the 0 value to the screen and then do the addition. I value is going to be 1. And now I'm doing the addition one more time. I value is going to be 2. 2 less than or equal to 10 is true. So that's how this condition works. And it's totally legal, totally valid, syntactically, semantically correct that you can play around it with your loop control variable, even inside the for loop body. And in this case, Both these update statements, I equal to I plus 1, are ensuring that our for loop will stop at a particular point of time. So these are all the variants of a for loop where you can start. You can start at a negative number, but ensure that it stops eventually. And what are you doing so that it stops eventually? You can start it with a positive number, but ensure the stopping condition. And what are you doing so that you reach the stopping condition? These are the questions. And it's not necessary that you have to follow increments of 1 or increments of 2. It's up to you. You have control over the way you are writing the update statements. And that's pretty much how we write or ask a set of questions to ensure that our for loops are terminated. And now, how to not write a for loop. So consider this snippet. I'm starting at 0, and the condition is that I greater than 0. So 0 greater than 0, which will be false. That means this for loop will be never executed. The control will never move inside the for loop body. So never write such for loops. All these 3 lines of code that I have here, it's useless. The code never executes, or the control will never go inside a for loop body. And now I made a simple change to this statement. I is 1, I greater than 0, I plus plus. This code, the problem with this code is that this code will execute infinite number of times. Why? Because I'm starting at 1. So this is my loop control variable. I is 1. When will I stop? I'll stop if I is 0 or I is negative, or else the for loop execution will continue. So now 1 is greater than 0. Print the value of I. Go to update statement. 1 plus 1 is going to be 2. 2 greater than 0, true. Go inside, print the value, update. I'm simply doing increment here. I'm adding 1 to a positive value, which will always be positive. And any positive value is greater than 0. So, and hence I have something called as an infinite loop here. So that's the problem with for loops. If you are not careful enough, you may write a for loop that will never execute, or you may write a for loop that keeps on executing and that will never exit. So that's the problem with for loops. Ensure that you're not writing these sort of for loops, and always ask these set of questions. What is the for loop for? Where are we starting? Where are we stopping the for loop execution? And are we writing the update statement correctly so that we start and we end and eventually ensure that for loop is terminated? So these are the key questions when it comes to for loops. And along with this video, I'm posting a set of questions for practice. Please practice these questions and let me know if you have any questions. Thank you.